basics. She is from Omaha, Nebraska, with a unique experience in farming and agriculture in rural, suburban, and urban environments. She graduated in 1979 from the University of Nebraska with the basics in natural resource and minors in the soil and agriculture education. She received a master's in public administration from the University of Kansas in 1988. Simmons has worked with NRCS in Kansas and Maryland, and in 2000 she moved to NRCS national headquarters with the farmland protection and community planning team. She has also worked with the National Conservation Planning Staff and Conservation Security Program. Moving to the National Conservation Technology Specialist 2005, she completed full-time work in 2016 at the Central National Technology Support Center located in Fort Worth, Texas. A few heights include resource concern, updates, and online tools for assessment, planning, and implementation, conservation, innovation grants, technology transfer with a focus on soil health with groups in Mexico and South Asia. United States Department of Agriculture Forest Service Baltimore City Ecosystem Study Team, the EPA Bay Tributary Strategy, and Kellogg Foundation Alliance for Sustainable Agriculture. She is also the founding member of Future Harvest CASA. She has also successful strategies to include grassland in USDA NRCS land protection program. She has affiliations with the Society of Range Management, the Soil and Water Conservation Society, Association of Women Scientists, and also with Women in Natural Resources. Now I request Cheryl Simons to kindly proceed. Dr. Shabir.
Well, thank you so much for that wonderful introduction, and thank you for the invitation. Are you hearing me okay, Shabir?
Yep. Yeah, I can hear you. Okay. Before you proceed, I want to say something. Sure. Let me remind to the participants that there will be a question and answer portion near the end. Please feel free to send in your questions through the question dialog box throughout the presentation. Now, I request our guest speaker, Professor Cheryl Simons, to please share their presentation and go ahead.
So it says that the host has disabled participant sharing. So I'm, can you
you can, yeah, a second.
You can share now, ma'am.
You can share now.
Okay. Thank you so much. So as my introduction started, I grew up in the Midwest and have had the opportunity to work in the far east part of the US and the far west part of the US, and then also in the Washington, DC and national headquarters, and with our regional offices, the technology centers. You know, it's so exciting to be a part of the World Soil Health Day and celebration. And I'm very happy to be here with you and share with you what I hope will be a little different perspective. I really appreciate great research and great communication of that research. But what I am really passionate about is technology transfer and getting the information to people that can use the information on a daily basis. And so let's go ahead and start. So I advocate whenever possible to partner with farmers and communities to improve agricultural research in soil, biodiversity and agro-ecosystems. And I'm speaking the importance of that from the journey from the basic science to the application. So often when you're doing research, there's times along the road that would be critical to have more input. And if you haven't started those communications and that partnering, it's hard to say, find those people or get the input you need to move forward. You may recognize this figure from Patterson and McKay. It's one way to look at soil ecosystems. On the far right, it has self-actualization.
Professor Cheryl, can I interrupt you? Can I interrupt you here?
Yes, of course.
Could you please speak loudly?
Yes.
All right, is that better?
Yeah, perfect. Please go ahead.
Okay, I appreciate that. And so this particular figure just is one way to look at soil systems and agro-ecosystems and how they affect people. And as you may notice, all the arrows are going one way. But as we know, of course, humans have a great impact on and ability to affect soil and function. And farmers and communities especially are near the nearest impact to the soil. So they also have a great impact on how new science and methods are received. So I was fortunate to work in Maryland in the late 90s, and a media company came to our group and was asking for help. They wanted to highlight water quality and how important it was. And so part of that, they decided to do a survey to start getting interest and information out about water quality. But they didn't know what to put in the survey other than water quality. And they said, well, is there anything else we could put in there to make it, kind of broaden so it looks like we're generally discussing things, but we really want to focus on water quality. And I added soil quality, air quality, and wildlife. And so what was interesting to me is that after they did their study and came back then with a media campaign, but they were surprised too that soil quality actually matched water quality in importance in farmers' minds. So they had asked, hundreds of farmers what was important to them. And even though the survey itself was biased towards water quality, the farmers had insisted and put soil quality up there as equally important to water quality. So that was the interesting input, having farmers involved in the actual process. You all may know about the story on potatoes, that a group developed a great potato. It was a very large potato with all the nutrients you would need. And they were very proud of their potato. And then the local people never used it. And they couldn't, what happened? Why aren't you using our potato? Well, it was too big. Women especially had to spend more time cutting it up. And they just didn't have that time. They rather use their normal sized potatoes and just move on. And so that may seem like an odd, small item, but that stopped that potato from coming into use generally. So one person I wanted to highlight in this that does this really well, and I was able to work with her lightly, but I always admired and greatly appreciated her work, was Dr. Nichols, who is a soil microbiologist. She worked for the Agricultural Research Service. And as she was working on research with fungi, she actually worked with a local group of farmers, and they would try out things on their farms. And this small group became leaders in soil systems and soil functioning and soil health. And to the point that one of the local farmers, Gabe Brown, that I have on the slide, is now a renowned leader in regenerative farming and speaks across the nation on conservation farming. So you're not always going to have a big home run with your research or working with partners, but there is opportunity. She now has her own private consulting business that is along the same lines. She's worked with Agricultural Research Service. She's worked with a Rodale Institute, which is a nonprofit private group looking at progressive farming techniques. And she's a big supporter, of course, sequestering carbon and recarbonizing our soils. But that all started from her working with these small groups and research at the same time. Some light examples I wanted to go over that may seem very old school can be looked at anew in new lights. And one of those is soil health cards. This was another thing that was done with farmers in small groups, talking about the good soils they've worked with, and then soils that need a lot of help or a lot of added components because they aren't producing it themselves. So a lot of fertilizer, a lot of tillage in the farmer's mind at the time. And so I was able to sit in with the small group in Maryland, and we looked at soils that were compacted and that really worked hard. And then we looked at soils all the way from that to under grasslands. And so you're comparing local soils to local soils. And I was skeptical to think that we could, as a small group, look at soils and then take some maybe pH test and decide whether it was good soil or not. I thought that was silly. And sitting with this group, it became apparent that through observation and a few minor tests, you could really come up with some good basic information on the soils. And so again, it's an example of something that may seem simple, but if you're doing it along with other research and tests, it can result in a big impact. So these were little booklets. Now they might be a phone app or an online tool. And as you can see, it was just a basic matrix of texture and tilth and compaction and infiltration. And all these are small little tests that you can do in the field, and then get a pH and a salinity test. So all these factors plus your basic soil tests can give you a good information. And most states did this in the US, where they would have a small group of farmers in each county, that's a small area in the state, get together and look and decide for their county what's a good soil and what may need more work and why that would need work, what can change to make that a better, healthy soil. Just because I'm originally from Nebraska, I had to put in the Nebraska example. And then another example of moving forward, and this is being advocated by farmers themselves again, is that the basic soil test isn't enough information anymore. And so here's one example of an additional soil analysis, which is looking at the soil food web analysis in addition then to a basic soil test to try and get a fuller picture of what's in the soil and what may be missing. You know, when we talk about the active portion of the soil, are we really getting it from our basic soil test, or do we need more information? And of course, I would argue we do, and that it's time for new and innovative soil evaluations. Our basic soil tests really started in the 40s, and they've changed with more chemical processes being added and tested, but really they haven't changed that much. And we have plant tissue tests, of course, but there's some groups starting to use nanotechnology to evaluate plants and soils. And we need a bigger picture for soil health to be able to say what is missing and what is needed. And so this may or may not be what you're working on in research or what you've talked about in research, but these are areas that you might consider. But regardless your area you're working in, again, it helps to have that real field experience, in time information coming back to you as you're doing research. I did want to mention some climate change actions going on also. This is from Cornell University up in Ithaca, New York. It's not a state university, it's a private university, but they have a online application called Climate Smart Farming. So that area can go and look on their university site and start to get an idea of options and strategies they might need to look at for current systems, and then as parameters change, as growing degree days change, they would have an idea of what they could move into. Now, I know not everybody has access to online all the time, but many areas have text systems that are working with producers from their phones, and so it's phone technology has really offered a wider availability of all these tools. So this also has information that includes the drought atlas and then specific area information in addition to a water deficit measure. For USDA, NRCS, we went in with different universities and groups in what's known as climate hubs. And so this is like a clearinghouse of climate-related information for the region. And so as you see on the map, the Southern Plains hub is where the Texas climate hub is. And what that tries to do is put climate information together, the known climate and climate change information for producers and everyone, actually.
Excuse me, Cheryl?
Yes.
Yeah. It seems like your presentation is little zoomed. Can you fit it to the screen? Some of the text is missing.
Well, I can't, I'm not able to see it on your screen. I'm only able to see it on mine. So I'm display settings.
Yeah.
Let's see.
It seems like it's little zoomed.
Little zooms.
No, Dr. Bangru, I don't feel it's like that.
Okay.
It's okay. It's
So-
okay. Slide
Okay,
is like that. No issue.
Go ahead then.
Okay.
Sorry about that. I'm happy to try and, it says swap presenter view with the slideshow. I don't know if that would help at all.
Okay. Okay, carry on.
Sorry about that. So one example that the climate hubs have come up with is a weather adaptation workbook, or climate adaptation workbook. And so this is a good way to focus on emerging climate science and information, and then use that in agriculture. So an individual producer or farmer can look and find soil conservation opportunities and limitations under changing climate. And it urges growers to look to the future and try out different scenarios of what may be happening, and then manage for that. So one thing might be, this is just an example, to reduce the risk of long-term impacts of extreme weather by reducing peak flows, runoff, and water erosion in an area where you have a lot of water, or in other areas where you would have less water. You would want to manage for drought and systems that are resilient to drought. So those are some examples. The strategies that are in this adaptation workbook are actually from a report, and I have it in the notes as a 2016 USDA Technical Bulletin 1944. And there's 124 example tactics or strategies to start looking at to address climate change on your farm. And this was put together, some of you all may know some of these names, Dr. Jerry Hatfield and Dr. Ray Weil, soil scientists in Iowa and Maryland, and then USDA and NRCS, of course, and some other NGO folks jumped in. And so this is taking the research information and putting it together. And so this may seem like the end result of what you're doing, but it's great to be able to evolve with the science as you're working on research, to be able to get this information quickly as it becomes known into these types of systems for actual use, especially because of the timeliness and time factor of climate change. Another issue I wanted to just mention lightly is that you want to be sure to be on the lookout in your research for bias, or to make sure you get everybody's story that you need to involved to have the best research output as possible. This may be not as tricky in when when you're working with soils and soil systems. But like with the potato, what they had not done is talk to the actual user of the potato to find out what was needed, or they would have come up with that their product could have been a success. And social sciences have been around for many years, but they've really in the last 10 to 20 years have become a staple in research activities. And so even though you may think that you don't have any bias, I would be surprised if you didn't, because I was able to be a part of a gender workshop, and I thought, well, some of those people probably needed this gender workshop, but you know, I as a woman, I don't need this. But I was able to be a part of that, and I was really surprised at how much my own biases were still intact, and I could be missing important information because I just wasn't asking or listening. I wasn't asking the right questions or listening clear and closely to what people were saying. So be sure to consider cultural and socioeconomic values attached to the different systems you may be working in, and ensure that you're getting the full picture of what people how they're responding to that research, because it's also how they will receive whatever outcomes you have are important, and that may be they may have that. You may be presenting something without knowing that it's biased, and they may be receiving it also that way. So it works both ways. Gender is so important. There's a consultative group for international agriculture research, CGIAR, and they right now are seeking a gender soil senior scientist. Sorry, not soil scientist, but gender senior scientist now. So if you know someone, they're looking for an applicant right now. So I am not urging anybody to shortcut safety or scientific method, but when possible, to move forward and move the science and application forward, to partner with local farmers and local communities and have them be a part of that research. When the product or your outcomes are clear, it will be much quicker for them to adopt them and incorporate them into their systems if parts of some of their farm leaders or some of the farmers have been a part of that. So it could consider additional avenues of use and synergy, and work with local farmers and communities and farm workers. Consider a phone application or tool or online tool as you're working on your system. And also put on a bias lens or gender lens while engaging in research work to make sure you're addressing all aspects that you need to address in your research. This all may sound very simplistic, but I will tell you it is very difficult and takes a lot of preparation and precision to make this work. Take a deep breath and take a step back from your own view and research, and see if there are connections or paths forward that may be the way to go and offer a new future and new partners in your research. So, as I mentioned, I'm passionate about technology transfer, and although you don't want to put out bad information, failure is a good thing. When you know, as you all know, when something doesn't work, you know that is a good thing to know, and then it allows others and yourself to move forward in a different way. And so if you're working on a project or a product and it doesn't work, that is as important or very important, and can be as important as the things that do work, because it helps point us to where we need to go. You want to listen to voices other than your own to help move that research product forward and fully realize the research investment. Again, none of this is brand new, but I urge you to take a step back and take another look, and I'm not urging you to go backwards, but to relook at the possibilities. And this may be former research, relooking at former research and with a new view might yield some new information. So I want to thank you for this opportunity to visit with you this evening. And again, it's very exciting that you're celebrating World Soil Health Day. And I want to turn it back over to Shabir and also my good friend, Dr. Khurshid. Thank you.
Thank you, Cheryl, for your wonderful presentation and highlighting the importance of taking research to the end user, that's farmers. Now, I would again request Dr. Aziz Mujtaba to please introduce our next guest speaker, Dr. Saima Khurshid, to this audience.
Thank you, Dr. Shabir. First of all, I am very much thankful to you for giving me this opportunity, because I really feel an immense pleasure to introduce our next speaker, because she has been my PhD batchmate. We have done our PhD together. First of all, good evening to all the participants and panelists. Dear friends, it gives me immense pleasure to introduce you today's guest speaker. As we have been together for our PhD, we have been PhD mates. I feel regarding the Dr. Saima Khurshid, I want to say she was a very good student. Right now, I am happy. She's a scientist at University of Nebraska, North Texas, who will be speaking on soil biodiversity and climate change. Regarding Saima, she is currently working in University of North Texas in the research and educational initiatives for urban agriculture program. Also working as an evaluator and liaison with the other Dallas community colleges for the success of urban agriculture program, to interact with leaders from the University of North Texas, agriculture organizations, academics. She's also involved in academics, including government agencies like United States Department of Agriculture, Natural Resource Conservation Services. She's also teaching the students of interdisciplinary approaches related to concepts of climate change and environmental science, which includes critical scientific thought, biodiversity, resource management, pollution, global climate change, resource consumption, and population growth. Emphasis on how these concepts affect and are affecting the human society. Regarding the personal information of the Dr. Khurshid, she was born in Sopore, which is very famous and known as Apple Town, and she has also graduated from Jammu, doing her primary work of the MSc on different organic manures on carbon enrichment from SCOS Jammu. While as she has completed her PhD on soil and crop sciences from SCOS Kashmir in 2012, with a primary emphasis on phosphorus management in rice soils using various organic manures. In 2013, she has moved to United States of America and joined the United States Department of Agriculture, Natural Resource Conservation Services at Fort Worth, Texas, where she worked as an advisor, soil and natural resource scientist at USDA and RCS, Central National Technology Support Center, Fort Worth, Texas. Her primary focus was supporting USDA and NRCS tremendously through public awareness efforts, including conferences, trainings to adopt best soil management practices, including and providing information on soil and natural resource conservation services. In 2016, she joined Dr. Fawad Jabbar in Biological and Agriculture Engineering Department at Texas A&M University as a postdoc fellow, and worked on a project low impact development infrastructure for stormwater management and understanding various microbial processes for removal of E. coli and other pollutants from the stormwater in bioretention cells, including preparing project reports, writing various research papers to consider them for publishing in various reputed scientific journals, writing proposals for National Science Foundation grants, and etc. Regarding her awards, she has been awarded Merit Scholarship from SCOS Jammu, and she has been a student. She has been also awarded with the Student Incentive Award from Soil Conservation Society of India. Regarding her affiliations, she is affiliated with Soil and Water Conservation Society, Soil Science Society of America. She is also the member of Global Society, Soil Biodiversity Initiative. She is also affiliated with the National Women in Agriculture Association, Advisory Board of National Women in Agriculture Association. I again want to thank Dr. Shabir for giving me opportunity to introduce Dr. Saima. Dr. Shabir, thanks, and over to you.
Yeah. Thank you, Dr. Aziz. Now, without further ado, I will request Professor Saima Khurshid to please go ahead.
Okay. Assalamu alaikum to everyone, and good evening to all who are in Indian Standard Time. Since I am in Pacific Standard Time, so it's 6:30 a.m. here. So I would like to personally thank you, Dr. Bangru, for the event invitation, and I wanted to thank Professor Tahir Ali, Professor Najjar, Professor Javed, and all other great mentors that has been my mentors during my PhD at the Coast University. So it's always nice to get connected with all my colleagues and all my batchmates. I want to thank Dr. Azam also for such a wonderful and brief introduction of mine. So before I get started, let me give you a brief introduction about me, like who don't know me. So my name is Saima Khurshid, and I was born and raised in Kashmir, and I graduated from Coast Kashmir and moved to United States. And currently I am working at UNT Dallas. I just want to thank everyone, the team of this, the organizing committee, Dr. Bangru and team for organizing this wonderful event. So it's really an honor and also an excitement for me to be a part of such a wonderful event. Thank you once again. And let's get started with my talk today. So today I will be talking about the soil biodiversity and climate change. So talking about the soil health and climate change, we all know that soils, they help to regulate the Earth's atmosphere. So healthy soils, they actually mitigate the impact of extreme weather events. As we all know that there has been certain agriculturists that have already been adopting different methods to increase that soil organic matter content and also to improve the soil health. So there are many methods that exist for increasing that soil organic matter in soils, and many of which are very easy to deploy, but there are yet to see the rapid adoption. So these include reducing how often soil is tilled, the erosion control measures, the soil mulching, and maintaining the ground cover. So crop rotation is also one of the adoption techniques, using different crop breeds or careful timing of grazing. So all these measures collectively, they seek to increase and preserve the amount of soil organic matter in the soils. So as such, what they can do is that they can improve the fertility rates and make the soil more resilient to weather events, and also secure the food supply by increasing the likelihood of a good harvest year. Because we all know that soils are the ones that have the potential to be an important carbon sink. We all know that healthy soils, they actually protect the planet from climate change. And it has been found, according to Columbia University, that soils remove about 25% of world's fossil fuel emissions each year. So just for your information, the Earth's soil contains about 2,500 gigatons of carbon. So that's much more than 3 times the amount of carbon in the atmosphere, and it's 4 times the amount stored in all living plants and animals. So what we can do is that we can think about the ways to increase that soil carbon storage. That's really important weapon against the climate change. So carbon in soils is greater than all the carbon that we have in our biomass and the atmosphere. So even small changes in that carbon pool are going to have a really large effects for us. So in short, if we can figure out that how to manage that soil carbon pool size, it could be really effective. Soil harbors tremendous biodiversity that to a large extent affects most of the key ecosystem functions of soil, like organic matter dynamics and carbon sequestration in soil, greenhouse gas emission from soil, or we can say the nutrient cover and soil water storage. So at the same time, the soil biodiversity, that's the soil biota, they are very sensitive to changes in soil environment and vegetation. which might be triggered by the ongoing climate change, as we all know. So consequently, these changes in the composition and biomass of soil biota may feed back to changes in many ecosystem processes. That's the nutrient cycling that's carrying out the decomposition and or other functions. So which may affect overall ecosystem response. So in short, we can say that there is a relationship among the climate change, soil biota, ecosystem functions, and land use management options. So soil biodiversity is one of the largest great frontiers in biological research. Since we already talked about that the soil harbors a tremendous biodiversity that affects most of the ecosystem services or functions of the soil, like organic matter dynamics and carbon sequestration in soils, and also the nutrient turnover. So here in this slide, you can see an overview of common microbes and animal groups that are living in the soils. So only a tiny fraction of these immense morphological diversity of soil organisms is known, and this is particularly true for the microorganisms. Like you can see, these include the viruses and bacteria, the more or many the fungal hyphae there are, and network-forming protist amoebae or the fruiting bodies of fungi. There are some protist slime molds or soil animals, or they are all morphologically diverse and include different types of worms with varying sizes. For example, we have some nematodes, we have some of that comes under the microfauna group, and we have earthworms that comes under the macrofauna group. So these highly diverse microarthropods are far more diverse than the worms and include such fascinating and animals such as the springtails, mites, or we can say the pseudoscorpions. So soil biodiversity contribution to this ecosystem is like nutrient cycling, the vulnerability of soil biodiversity and services, or they can optimize soil biodiversity for human well-being. So how actually climate change affects the soil biodiversity? So when we talk about the global climate change, it's a very hot stuff. So global climate change occurs because of the changes in the climate of Earth as a whole that lasts for an extended period of time, we may say decades or longer. And this global climate change actually refers to the changes that are forced by certain human activities that change the atmosphere, or a change in global or regional climate patterns that are attributed to the increased levels of atmospheric carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, or chlorofluorocarbons. All are the greenhouse gas emissions. Here's an overview of contribution of different sectors in world climate change. So transportation sector, the greenhouse gas emission from transportation primarily comes from burning the fossil fuels for our cars. We are using trucks, ships, trains, and over 90% of the fuel used for transportation is petroleum based. That means which includes primarily the gasoline or diesel. And then talking about the agriculture has also some share. It's about 13.5% contribution to the greenhouse gas emission. And greenhouse gas emission from agriculture comes mainly from the livestock. For example, we have cows or the agriculture soils, and also from the rice production. So these are the three important greenhouse gas emissions from our rice fields or from the fertilizers or carbon dioxide emission. So rice feeds half of the population, global population, and rice paddies contribute about 20% of this agriculture methane emission. So it covers only 10% of arable land. There are certain anthropogenic climate change that's predicted to double methane emission from rice production by the end of the century. Certain ruminant animals there are that are the largest single source of anthropogenic methane emission, with about 19 to 48 times larger carbon footprint for ruminant meat production. there is the agriculture, which is the largest emitter of potent greenhouse gas, that's the nitrous oxide, which is released by the microbial oxidation and reduction of nitrogen. So I have a question. What if there is no microbes on the planet? So no microbes on the planet, there will be no oxygen, no food digestion, no nutrient cycles. There will be no plant establishment and growth. So we will have to say goodbye to everything. So what will happen after death? The organisms would not return those nutrients back to the soil. So it will completely mess up our ecosystem without microbes. So we can imagine if there are no microbes, you will have to walk on the dead bodies of all animals and humans. So it would have been easy to find our ancestors if we don't have microbes, right? So one more query is that whether these microbes, they are involved in global climate change. So we might say that it's not that easy to say that they are the sole culprits. They are sole responsible persons. However, under suitable conditions, they are the main culprits for producing these greenhouse gases. So like we already discussed, that there are three most important greenhouse gases that are the carbon dioxide, methane, nitrous oxide, and these have increased dramatically in recent years. So the microbes that are involved in the methane emission or the methane, that means they carry out the process of methanogenesis. The carbon dioxide is released through respiration or decomposition of organic matter, and nitrous oxide is released through the denitrification process. So fungi and soil bacteria, they are the decomposers and play a major role in the carbon cycle as they break down the organic matter and release the carbon dioxide back into the atmosphere. And in case of nitrogen cycle, there are certain nitrogen fixing bacteria, like we have the rhizobium that fix nitrogen, which means they convert the nitrogen in the atmosphere into the biological nitrogen that can be used by the plants to build the plant proteins. So like I said, the climate change, it affects the microorganisms too. So agriculture practices that disturb the soil, for example, talking about the tillage practices or planting the monocrops, or we remove always the crop residues, or sometimes the excessive use of fertilizers and pesticides or overgrazing. What they do is that they expose the carbon in the soil to oxygen. So allowing it to burn off into the atmosphere. There is sometimes deforestation and draining of peatlands. They also cause soils to release that carbon. Or in short, we can say that shifts in climate, they can influence the structure and diversity of these microbial communities. That might be directly, for example, seasonality and temperature, or indirectly, for example, they might affect their plant composition, the plant litter, or root exudates. So microbial diversity influences the plant diversity and is important for certain ecosystem functions. Here are some anthropogenic factors that affect the soil biodiversity, which includes the mining, deforestation, agricultural land use intensification, sealing, and that also those that come directly from human-induced changes like pollution. We might talk about the changes in climate, such as drought or acid rain, or certain pathogen invasions. So these changes are actually linked to the rapid growth of human population and an increasing proportion of land surface. So in addition, the land is being used for mining activities to support us with energy, and for agriculture to produce the food, feed, and bioenergy. So for food production alone, about 1 billion hectares of land could be turned into agriculture, which is managed land by like 2050. So furthermore, there are certain agriculture practices that are being intensified to support the growing human population. So these intensified agriculture practices, they actually depend upon the irrigation, the use of heavy machinery, and increased application of chemical fertilizers and pesticides. So in short, we can say that these practices that we are adopting cause habitat modification, and they immediately change the soil structure and also affect the microbial communities. That means the microbial communities, they are becoming the bacteria dominated, whereas earthworms are killed, and mycorrhizal fungi, they are disrupted by certain tillage practices and other agriculture practices. So climate change can reduce the herbivory, also resulting in overall alteration to global nitrogen and carbon cycles. So they can reduce the terrestrial carbon sequestration. There are certain experiments that have been carried in the labs that have shown that the soil respiration and carbon dioxide release can double with every 5 to 10%, 10 degrees centigrade increase in temperature. And plant release is about 50% of fixed carbon, which is available to the microbial growth. So higher carbon dioxide levels in the atmosphere, they actually increase the primary productivity and forest leaf and root litter, which leads to higher carbon emissions due to microbial degradation. So what are the different mitigation strategies for the climate change? Let's now talk about them in detail. So agriculture can be a part of the solution. So increasing the carbon sequestration through land management practices, rotation, the crop rotations with the cover crops, green manuring, agroforestry, or we could reduce global carbon emission by 5 to 15% by conservation tillages, adopting those techniques. Organic farming, it enhances the carbon storage in soils. So conservation tillage, when we talk about that, tillage practices result in loss of soil water that represent an important threatening process for soil microorganisms, as well as it causes the depletion of soil carbon stocks. We can say that improved tillage that returns the crop residues may improve soil biodiversity, but there are certain carbon stocks and water holding capacity that might be improved too. So at a time when the carbon storage on agricultural land is a major issue, it may be proved to be that the soil organisms are the major beneficiaries from management practices that are aimed at soil carbon sequestration and storage. One more question is that, can these microbes help to save the planet? If anybody asks me, I would say yes. So an improved understanding of these microbial interactions would help to underpin the design of measures to mitigate and to control that climate change and its effects. As we all know that in agriculture, there is a progress in understanding the ecophysiology of microorganisms that can reduce the nitrous oxide to harmless nitrogen. So for mitigating those emissions, the use of certain bacterial strains with higher nitrous oxide reductase activity has also lowered the nitrous oxide emissions from soybean. So there are a lot of researches that are going on and have been done in the past. So that say that by using these bacterial strains with higher nitrous oxide reductase activity, they have lowered the nitrous oxide emission to some limit. Or if we talk about the methane emission, so we can say that manipulating the human microbiota and breeding programs might target host genetic factors that change the microbial community responses. That are possibilities for reducing that methane emission from those ruminants. That means the cows or the livestock, etc. Biochar can be also used for the mitigation because it's an example of agricultural solution for broadly and indirectly mitigating those effects of climate change. So we all know that biochar is produced from thermochemical conversion of biomass under oxygen limitation, and it improves the organic matter retention by reducing the microbial mineralization And it also reduces the effect of root exudates to releasing organic material from minerals. So thereby it can promote the growth of grasses and reduce the release of carbon. One more option is the bioremediation. So what actually is bioremediation is the process of using those biological microorganisms to break down those hazardous materials and substances into the less toxic or non-toxic products. So it can build up or speed up the natural biodegradation process that occurs in nature. So by using these bioremediation measures or bioremediation technology, we are able to reduce the certain pollutants and other damaging effects in the soil. Agriculture is also pioneering the use of microbes to enrich the crops by helping plants harness and use the nutrients and water more efficiently. So there is a lot of companies that are doing that. For example, we have the Bayer Crop Science and there is Ginkgo Bioworks that are working to create those microbes that will help crops like corn, wheat, or rice to extract the nitrogen from air to use on their own. So in short, we can say that this would radically reduce the need for man-made fertilizers and be a powerful step towards a carbon zero future for the agriculture. Here are certain adaptations to the climate change. That means using new varieties, that's the drought or heat resistant varieties, new farm management practices, or changes in land use, or we can say the watershed management. Let me now talk in brief about the innovative technologies that can combat the climate change. So how the Internet of Things is transforming the agriculture sector. So in the scenario of IoT-based smart farming, a system is built to monitor that crop field with the use of certain sensors. So soil moisture, temperature, humidity, light, etc. They are automated to the irrigation system. So what can happen is that this way the farmers will be able to monitor the field conditions from just anywhere, regardless of their current location. So as compared to the conventional farming nowadays, IoT-based smart farming is way ahead in the game and is highly efficient. So it can help ensure a more sustainable future, actually. So farmers are taking steps towards a carbon zero future using cutting-edge tools and farming practices to remove as much of it, and if not more, greenhouse gases from the atmosphere than a farmer emits. Talking about the digital agriculture, the digital tools and precision agriculture techniques, they enable the farmers to have a more intimate and informed understanding of what is actually happening in the fields. So with big data, processing of structured and unstructured data, cloud-based applications, or we can say the automation in agriculture, business process management, for example, like I said, there is a company that's the Bayer. They are working on software platforms that offer monitoring tools, which help the farmers use the pesticides more efficiently, reducing the greenhouse gas emissions and pesticide runoff into the water, or precipitation alert let farmers know which field may be too wet or too windy to apply the pesticides, so they can avoid the costly treatments and unnecessary fossil fuel use. We have certain automatic watering and irrigation strategies. So subsurface drip irrigation is already a prevalent irrigation method in US that allows the farmers to control when and how much water their crops receive. So by pairing these subsurface drip irrigation methods with sophisticated Internet of Things or IoT-enabled sensors, they continuously monitor the moisture levels and plant health. So farmers will be able to intervene only when necessary, so otherwise allowing the system to operate automatically. So what actually can be done? So first, we must admit that climate change is everyone's problem. So no agency, government, or scientist can fix it for us. We're all in this together. So we got here because of our lifestyle. So our lifestyle has to change. Here is what you can do. We can reduce the emission of greenhouse gases, attempt to develop certain alternative energies, or allow the emission to continue, but we have to prepare for global climate change then. So allow the emissions to continue and as normal and leave the preparations to individual countries. Or what we can do is that we can combine any of the ideas that we already discussed and come up, also we can come up with some of our own unique plans. So concluding my talk, I would say that climate has the obvious direct effect on agriculture production. And the reverse is more apparent than ever as greenhouse gas emissions. The development and effective diffusion of new agriculture practices and technologies will largely shape how and well farmers mitigate and adapt to climate change. So this adaptation and mitigation potential is nowhere more pronounced than in developing countries like India, where agriculture productivity remains low, the poverty is there is vulnerability, and food insecurity remain high, and the direct effects of climate change are expected to be especially harsh. So climate change is the beginning of the end. Our earth is heating, so is the environment. Now it's up to you what we can do. Thank you so much for your time. So before I drop the call, I would just say that in addition to the above mitigation and adaptation techniques that we are using, we are somehow adding this carbon to the atmosphere. So we can also reduce our carbon footprint. So what's your ecological footprint? You can just go to this link and you can calculate your ecological footprint and see that how much you contribute to the carbon emission. Thank you so much. Thanks.
Thank you, Dr. Saima, for a very nice presentation and elaborating the importance of microbial diversity to the climate resilient agriculture. Now I will go to the question answer session. Here I would request my colleague, Dr. Iqbal, if there are some questions, may please be put forward to our guest speakers.
I must say good morning to our speakers and good evening to others from India and Pakistan. There were some questions from our audience, but there were some questions that were already answered by Professor Chernail Simmons. Now, one question is from Zuhur Mujaddid from Pakistan. He asks, any of the panel speakers may answer it. How a small farmer can get benefits from biochar and also bioremediation technologies, since biochar is very costly and bioremediation is unknown to farmers. Are you getting me, Dr. Saab?
Dr. Cheryl?
Well, I can start and maybe Saima can jump in.
You can go ahead, Cheryl.
So biochar, there has been some work on what one would call homemade biochar. And so it may be expensive in the area, but there may be an opportunity to do a local homemade biochar. I will try and send some information to Saima and the leaders of the presentations. So I know if you are packaging it for massive quantities in a big compressor heat machine, that becomes expensive. But they have been doing some work with local it's a slow burn for biochar. So I'm not sure though that it's the same quality would be my question. But so that might be an option. And then as somebody asked the same question before, how do you do these things in areas that are either remote or and poor? And it is tough. And that's where, you know, great research projects could be, is right there in those areas to help answer those questions. But it becomes even more critical to have local buy-in from the leaders of that it might be farming or helping farmers in that group to try some of these different technologies, because it is just hard if you keep to traditional systems and there isn't enough. In general, it is hard to then start saying, well, let's leave this area over here for our test. So it would be critical to have the support of the local folks, but that's where we need partners, FAO and others, to help jump in. Simon, do you have something to add?
No, I think I will go with you. Any other questions?
Yes. There is one query from Dr. Jigmit. She is our colleague from Ladakh. She is asking Dr. Saima particularly. She is asking.
She is a good friend of mine. Yeah, I know her.
Yes. She is asking how much urea is contributing to climate change. Urea application, rather.
The nitrous oxide. So agriculture in general is like 13% contribution to greenhouse gases to the climate change. So nitrous oxide has a great share because of the use of those nitrogenous fertilizers that we are adding to the soil, the inorganic fertilizers. So that has a great share. So it's like 13% from the agriculture point of view.
Thank you. These were some of the queries raised by our audience. Rest are just as usual. Thank you.
Okay, thank you, Iqbal.
Thank you so much, Dr. Iqbal.
Yes.
Thank you.
So thank you. I would like to request if there is anyone from panelists who would like to give a feedback.
Yes, Mr. Shabir,
Yeah.
Can you hear me?
Yes, sir. Yes, sir.
Thank you very much. It was a nice lecture and I am very happy to see Saima. You know, when I got the message today that she is going to deliver a lecture today, it was rather unbelievable for me, because I was not knowing that she is working with the agriculture in USA. So first of all, I would like to congratulate Dr. Saima for her achievements. Now she has continued her profession over there. Otherwise, most of the people who leave India and go to another states or somewhere else, they change their line. But she is continuing her research, and we are very proud of her that she's doing well there. And it was very a good lecture, and it was very nice to hear her today. I can say I have no words that it was a beautiful lecture. One thing I will tell that in one slide, she was telling that microorganisms, what if there is no microbes on the planet? You know, I have my own personal saying in this. I call these microbes engine of the planet. Just you have a machine, you have a vehicle, there is an engine. Now you take engine out of the vehicle will stop, it will not run, and you cannot run it. So when you these microbes, if they cease to exist, our whole planet will cease to exist. As they took part in the decomposition of all wastes, what will happen? As she told, dead bodies, they will be like that. This, whatever will fall on the earth, it will remain over there. So I call them the engine of the planet. It was a very nice. Then, so far as these decline in biodiversity, we in India have a problem of degradation. I think the problem of degradation is the second one next to the population growth as the biggest environmental this problem which we are now facing. So I don't know what about the states, but we have a lot of degradation problem here. Then one more problem which is adding to the loss of biodiversity here. You might be knowing that during November, December, yeah, just yesterday, Dr. Kukal was telling the crop residue burning. Usually in Punjab, 18 to 16 million tons of crop residues are burned annually. So what happens, these nitrous oxide, carbon monoxide, carbon dioxide, particulate matter go into the atmosphere. But not only that, we are losing our biodiversity also. The temperature during this burning at the surface, it may rise up to 50 degrees, 60 degrees Celsius, with the result that some of the microbes which cannot tolerate the high temperature, they will die. So these some of the problems which we are nowadays facing in India. Now, one more thing that I would like to share with both of the panelists is that recently I was watching I think video somewhere where they in some states of these United States, some of the states, that they have launched a program for improving, for enhancement of the soil health. And they convince the farmers that we have to improve the soil health. And one of the measures, I can say, that was the cover crop. And maybe they might be knowing better that if I'm correct, that I think the government is of USA is giving farmers some incentives even for growing the cover crop, so that the soil fertility may enhance, because we have a problem of no soil health. Our soils are sick. I can say the word sick, not ill. When we say a sick, it means something alarming, that we have to take remedies. So that is some things I want to share with you. So far as a biochar is concerned, yes, it has advantages, but it has a disadvantages at the same time, because we have to produce that product which may be easily available to a farmer, which may be less expensive, which may be enough just for the application. Otherwise, if a material is there, that is, it is process is of the formation or manufacturing is very complex, that we have to sometimes give a farmer those techniques or those products which are easily can go and can do it at a farm level also. So these were some of these I wanted to share with both of the panelists. And I once again thank both of them, that it was a very nice presentation, and they have taken out their time to share their valuable knowledge with us. Thank you very much. Thank you.
Thank you.
Just want to thank Dr. Wani, Professor Javed, for these kind words. I was really excited when I got an email from Dr. Bangru, that an invitation from Dr. Bangru, that are you going to present? Would you like to present at the World Soil Day event? So I think it was a great platform to get connected with all my colleagues and batchmates and the professors, my mentors. I don't know whether Professor Najjar, he is here or he is listening to me, but I'm really very thankful to all of my professors, my mentors, for sharing their knowledge. When I was in SCOST for like 4 years, I have been there. So when I completed my PhD program. So thank you so much once again. And thank you all our hosts for this great event. And thank you for your attention. Thanks.
Thank you, Dr. Saima. Now, before we wind up, I have one query for Cheryl Simons. Since United States is having a very strong soil information system, I just want to know what is its role and how far it has gone in sustainable soil management at farmers' field level.
Could you say that one more time, Dr. Bangru?
Since USA is having a strong information system, soil information system online, how far has it been gone and what has been its application?
So I've been answering some questions in the chat, and it's really along those same lines. Is that how do you get people who to change or do things? They regardless of levels, people think they don't have or they're concerned about money, whether they can afford it, whether it'll be a change. One thing I have noticed in the U.S. is that people tend to say, "This is how we've always done it." This is how my father did it. This is how my grandfather did it. But when you talk to the grandparents and the fathers, that's not exactly how they did it. It's really a generational thing. You think as a person in a certain age group, you think that's how it's always been done because that's what you know. That's not how it's always been done. And so having intergenerational groups come together is helpful because usually someone will speak up and say, no, that's not how we used to do it. We didn't have this or we didn't have that. And so our farmers are actually often leading the way in some of these soil systems changes. It's really hard if you have large equipment to change out equipment, but the smaller farmers are actually kind of leading the way because they don't have as big a farm machinery costs. And then the big farmers will look at that and say, well, that's a really good idea, like no tillage or zero tillage. But you can't start out and do it all at once. You have to start small and learn as you go. So that's really the thing that's changing, is just having those communications with farmers communicating with farmers. Does that help?
Okay. Yeah.
Thank you. Thank you.
Once again, I thank Cheryl and Saima. Now, before we end up, I would request everybody to please
Dr.
open
Bangru.
your camera. Yeah.
Hello.
Yeah,
Dr.
yeah.
Shabir, can you hear me?
Yes, please, sir.
Can I come in for a second?
Yeah, please, sir.
Okay. In fact, the presentations made by both the speakers were amply good, and I believe they carried enough information for the sake of our students and faculty as a whole. But one query, not a question, in fact, but one query I want to have from Professor Simon, that once she spoke about the soil health card, and if you view those soil health cards in the context of our India, normally we are mainly focusing towards NPK, nitrogen, phosphorus, and potassium health. Am I right? Am I audible?
Yeah.
Yes, you are audible, sir.
Yes.
So our main focus is towards NPK. We want to list what are the deficiencies and what are the discrepancies insofar as the fertilizer, ingredients is concerned. I would like to know from Professor Simon, in her expert opinion, what are the main 3 things or 4 things which we should enlist in our soil health, so that on the first sight of it, we'll be able to understand that what exactly is the lacuna with the soil of a particular farmer, and what are the issues which one should address immediately, particularly in view of the microbial position. Normally, if we talk of our system, perhaps we are not attaching any importance to the microbes. Our main focus is on NPK. Can I have some input from Professor Simon?
Yes, thank you for that. Thank you for that question. And I think that's exactly why we were doing soil health cards, is that traditionally our farmers tend to only look at synthetic fertilizers. What do we need to add? Instead of looking at the soil as a factory in itself, with treated correctly, will produce many of the things that we need, or be ready to better accept additives that we can add. And so any kind of soil structure or soil or organic matter, visual organic matter, but soil structure and organic matter are important aspects of soil health that you can see, and then they help a great deal. So I hope that helps. I've sent the PDF information to the presenter leaders here, but if you just Google soil health card and US, you would find some of these examples. But those are the important things. So appreciate it so much. Thank you.
Thank you very much.
Thank you. Actually, we have run out of time, but still, I would request everybody to please open up their camera for a group photograph. Well, I thank once again Professor Cheryl and Dr. Saima for joining us. It was really nice to hear you and hope to see you in future programs as well. And once again, from our organizing committee, on behalf of our organizing committee and university, I thank you for joining with us. Have a nice day.
Have a nice day. Thank you. Thank you very much.
Thank you all for your attention. Thanks.
Thank you.
You all have a
Thank you. All the best.
Thank you. All the best. Thank you.
Very much, dear.